This is Miss Steele's Precalculus class, section 7.3. We're going to be dealing with double angle, half angle, and product sum formulas. The double angle formulas that you guys need to be familiar with. And these ones highlighting right here. So sine of 2x is equal to 2 times sine of x times cosine of x. We'll see the derivation of the double angle formula. So sine of 2x can be rewritten as sine of x plus x. And then just using the sum angle formulas that we learned the previous day, we can rewrite this as sine of x times cosine of x plus cosine of x times sine of x. This is equal to, since we have sine of x times cosine of x listed twice, this is just equal to 2 sine of x cosine of x. A very simple derivation. Another one we need to be familiar with is cosine of 2x. Cosine of 2x is equal to cosine squared of x minus sine squared of x. It's also equal to 1 minus 2 sine squared of x. And it's also equal to 2 times cosine squared of x minus 1. So, similar thing, we're going to show the derivation of the cosine double angle formulas. So cosine of 2x can be rewritten as cosine of x plus x, which using the cosine sum formula we learned the previous day, is equal to cosine of x times cosine of x minus sine of x times sine of x. So therefore, cosine of 2x is equal to cosine squared of x minus sine squared x. We could also substitute cosine squared of x in for 1 minus sine squared of x. We get this just from one of our Pythagorean identities we learned in 7.1. And substituting 1 minus sine squared in, or substituting in 1 minus sine squared of x in for cosine of x, we are left with 1 minus sine squared of x minus sine squared of x. Since we have 2 sine squared of x, this is the same thing as 1 minus 2 sine squared of x. And the third way is to substitute in sine squared of x, where we see 1 minus cosine squared of x. This is how we get cosine squared of x minus 1 minus cosine squared of x. And then distributing this negative to the 1 and the negative cosine, we end up with 2 cosine squared of x's, so we have 2 cosine squared x minus 1. And the other double angle formula you want to be familiar with is tangent of 2x, which is 2 times tangent of x divided by 1 minus tangent squared of x. For example 1, it says if cosine of x is equal to negative 3/4 and x is in quadrant 3, we're asked to find cosine of 2x and sine of 2x. So let's start out by drawing a picture. We know that we have a triangle in quadrant 3, or an angle in quadrant 3. So here's our angle x, and if this is our right triangle, we know cosine is adjacent over hypotenuse. We have negative 3 over 4. And to find our missing term, we can call that b. We'll take negative 3 quantity squared plus b squared and set that equal to 4 squared. So we have 9 plus b squared equals 16. Subtract the 9, so we have b squared equals 7. Then b equals the square root of 7. So using one of our cosine double angle formulas, let's say cosine of 2x equals 2 times cosine squared of x minus 1. This is equal to 2 times negative 3/4 squared minus 1. Negative 3/4 squared is the same thing as positive 9/16. So we have 2 times 9/16 minus 1. This is equal to 18/16 minus 1, but using a common denominator, we'll have a common denominator of 16. So we have 18/16 minus 16/16. So we can subtract straight across. 18 minus 16, just 2/16, which we can reduce to 1/8. So cosine of 2x is equal to 1/8. Now thinking of sine of 2x, we know that the double angle formula for sine is just 2 sine x times cosine of x. So sine of x is opposite over hypotenuse, so we have 2 times opposite side is square root of 7/4, or square root of 7, then hypotenuse is 4. And cosine is just that negative 3/4. This ends up equaling negative 6 square root of 7/16. Oh, and I apologize. Since we are in the third quadrant, sine is negative, so it's negative square root of 7/4, which would end up making our final answer positive. Sorry, that was my fault. So we have 6 square root of 7 divided by 16, which we can reduce the 6 and the 16, equal 3 times the square root of 7/8. So sine of 2x is equal to 3 times the square root of 7, all divided by 8. Half angle formulas are other formulas that we will need to become familiar with throughout Chapter 7. So these half angle formulas that we need to know include the sine, cosine, and tangent formulas. So we have sine of x/2 is equal to plus or minus the square root of 1 minus cosine of x divided by 2. Cosine of x/2 is equal to plus or minus 1 plus the square root of 1 plus cosine of x/2. And then tangent of x/2 is equal to 1 minus cosine of x divided by sine of x, and it's also equal to sine of x divided by 1 plus cosine of x. So let's take a look at a couple examples to get familiar with these formulas. Example 2 says use a half angle formula to find the exact value of sine of 165. Whenever it says exact value, that tells us that we need to not just plug into our calculator, but we need to find, typically it's a fraction. So let's do some math. We know 165 degrees is in quadrant 2. And in quadrant 2, sine is positive. Since sine is positive, we know that we will end up using the positive square root in our formula. So we're going to take sine of 330 divided by 2, because 2 times 165 is 330. So that is equal to the positive square root of 1 minus cosine of 330, all divided by 2. Is equal to the positive square root of 1 minus the square root of 3/2 divided by 2, because cosine of 330 is square root of 3/2. This is equal to continuing the positive square root. We're going to be splitting up our fractions. So we have 1/2 minus the square root of 3/2 divided by 2, which is equal to the square root of 3/4. Which this is equal to finding a common denominator, the positive square root of 2/4 minus the square root of 3/4, which we can pull that 1/4 out, and this becomes the positive square root of 1/4 times 2 minus the square root of 3, which is equal to positive 1/2 times the square root of 2 minus the square root of 3. So the positive 1/2 of the square root of 2 minus the square root of 3 is our final answer. That is equal to the sine of 165. Looking at our next example, it says using half angle formula to find the exact value of tangent of pi over 12. This is easier to find using degrees. So we're going to take pi over 12. In order to convert this to degrees, we will multiply by 180, divide by pi. That way our pi's will cancel off, and we are left with 15 degrees. So tangent of pi over 12 is equal to tangent of 15 degrees, which using our half angle formula is equal to tangent of 30 degrees over 2. So the formula we can use is sine of 30 degrees divided by 1 plus cosine of 30 degrees. So we know sine of 30 degrees is 1/2. So in our numerator we have 1/2. In our denominator we have 1 plus. The cosine of 30 degrees is the square root of 3 over 2. So we have 1 plus the square root of 3 over 2. To get rid of our denominator, we want to multiply by 2 over 2. So in our numerators, our 2's will cancel. In our denominator, we need to be a little more careful. We need to be sure that that 2 gets distributed to both the 1 and the square root of 3 over 2. So we're left with 1 over 2 plus the square root of 3. So if we have 1 over 2 plus the square root of 3, to get rid of that radical in the denominator, we need to multiply by the conjugate. So we need to multiply by 2 minus the square root of 3 over 2 minus the square root of 3. Doing so, on the numerator, we're just going to be left with 2 minus the square root of 3. In the denominator, we have 4 minus square root of 3 squared, which is just 3, so 4 minus 3. And then simplifying this further, we just have 2 minus the square root of 3, all divided by 1, or just 2 minus the square root of 3.